Hello dear student, how are you? Today I am going to discuss about the tool life. So today we are going to discuss about the numerical also. Today my totally focused on to complete the tool life, okay, in a very successful manner so that you can understand this concept beautifully. So that's why today I will read your comments little bit, okay. So please don't mind first of all. Uh, but if you have any doubt in this session, okay, you can ask me on my Telegram group. You know where to ask? On my Telegram group, you can ask me directly. Got it? So let's start about the tool life, dear student. Because what do you mean the tool life? The meaning of tool life is basically a useful life of the tool where it can cut the workpiece without any defect. That is the tool life. Got it? So it is a predetermined numerical value because before machining you know that type of tool will be cut that much amount of what? That much amount of time. That much amount of time it will cut the workpiece successfully. And how can I know? Because I know the machining condition, I know the workpiece, I know the tool material. That's why I am able to calculate the tool life. Okay, before machining I can say that the tool will be run up to 35 minutes, 90 minutes and so ever. Got it? So tool life will be represented by various okay, predetermined value like actual cutting time. By telling the actual cutting time you can say the tool will be over. You can say that much MRR, okay, material removed, then after the tool is not useful for us. Number of parts produced means suppose that a tool is going to be produce 100 parts, then after a tool is not useful. Cutting speed, sorry, cutting speed of a given time, okay, and also the length of the work machine means that much after cutting that much length of the workpiece the tool is not useful. And what do you mean by the cutting speed? If you are using a tool at 60 meter per minute, then the tool life will be let's say 30 minutes. But if you take above the 60 meter per minute velocity, then the tool will be wear very fast. That is a meaning. Got it? So this expression to calculate the tool life, okay, there is a expression and it is given by the Taylor's, okay. This is V T to the power N equal to C, right? Where V is what? Where V is the cutting velocity. Where V is the cutting velocity. One should be remember carefully about the unit. Cutting velocity should be in meter per minute. T is the tool life. It should be in minute. N is the exponent depend on the tool material. And C will be the constant which depend on the tool material, workpiece material and machining condition, right? So here if I am going to simplify, okay, if you want to calculate the tool life, then what you will write? Then what you will write? You will write again, I am going to write V T to the power N equal to C, T equal to C by V to the power 1 by N. What is the meaning? The meaning is that tool life is inversely proportional to the velocity plus tool life is directly proportional to the cutting condition, okay. That is the meaning. Now, if suppose that the cutting conditions are same and if you are using same tool and same workpiece at a different velocity, then how can you equate? Suppose that the machining condition, okay, machining condition, okay, is same in two different case, okay. But you are changing the velocity, not velocity, okay. Apart from velocity, you can changing the cutting condition, Apart from cutting condition, you changing the cutting velocity. Okay, cutting condition means workpiece same, tool same, all the conditions are same, but by using similar type of tool, you are changing the cutting velocity. Okay, suppose that in case 1, velocity is V1, then you will get corresponding tool life T1, right? Suppose that in a given condition 2, you are changing velocity V2, corresponding to V2, you will get the tool life what? T2, right? Now, how can you write this? Now, everything is same, cutting condition is same, so C is same, okay, C is same in both the case, even the tool is same, so N is same, so how can you write? You can write V1 T1 to the power N equal to V2 T2 to the power N. You can equate by this. Got it? So, let us try to attempt a question. There is a orthogonal machining operation, right? There is a orthogonal machining operation. The tool life obtained is what? 10 minutes at a cutting speed of what? 100 meter per minute, right? Now, when you change the cutting speed 75 meter per minute, okay, then the tool life becomes what? Then the tool life becomes 30 minutes. Now, you have to find the index value N. Here, the cutting condition and the tool is same. So, what you can write? You can write that V1 T1 to the power N equal to V2 T2 to the power N, right? Here V1 is what? V1 is in first condition, this is the V1 and this is what? This is T1, right? This is what? This is V2 and this is what? T2, right? So, how can you write V1? That is 100 into T1, that is 10 to the power N. V2 is what? 75 into T2. T2 is what? 30. Okay, 30 to the power N. Now, by using the calculator, you can solve this. Got it? You can solve this. So, once you solve, and it is what? 100 into 10 to the power alpha x equals 75 into 30 to the power alpha x, shift solve equals, then you will get the value of what? N. And here N comes 0.26262. Here you get 0.262, right? Pretty simple question. Now, let us move and see another question. Okay. Now, let us see another question. Now, what is the question basically? Here, please see the question carefully, because this question was asked 2 times in a gate and it will be repeat. Okay. It will be repeat again and again. Now, there is what? There is a tool A whose tool life exponent N is given 0.45 and constant is 90. Means there is a tool A, and tool A, I am representing tool A by 1. Okay, tool A, I am representing it by 1, and tool A has a N1 value is what? 0.45 and the C1 value 90, right? Now, there is a tool B. Look, there is a tool B. Similarly for tool B, okay, tool B I am representing by 2. So, you can write down tool B, right, tool B. So, with N2 equal to what? 0.3 and with C2 equal to what? 60. C2 equal to 60. So, what will be the cutting speed above which? What will be the cutting speed? Okay, above which tool A will have a higher life than tool B. Actually, he wants to know that tool A is greater than equal to tool B at which velocity? At which velocity? What is the meaning is that we are keeping velocity same in both the case. V is same, okay, in both the case, V is same in both the case. If you are keeping velocity same in both the case, but in both the case tool is different, cutting condition is different, then according to that, okay, we have to find that velocity which is same in both the case, so that the tool life of A should be greater than equal to what? Tool life of B. So how can you write TA? You know, basically instead of TA I will use what? I will use 1. Okay, I will use T1 and T2. Now you know V1 T1 to the power N1 equal to C1. So what is T1? T1 is C1 divided by V1 to the power 1 by N1, right? Similarly, you can write that T2 equal to C2 divided by V2 to the power 1 by N2, right? Now you know T1 is greater than equal to what? T2. T1 is greater than equal to what? T2, right? Now, so what will be the T1? T1 is basically you can write C1 divided by V1 to the power 1 by N1 greater than equal to C2 divided by V2, okay, either V1 and V2, right? V2 to the power 1 by N2. Now it is greater than equal to, now what is C1? C1 is what? 90. Velocity is same in both the case, V. What is N1? 1 by 0.45 greater than equal to, what is C2? That is 60. Divide by what? V. 1 by what? N2? 0.3. So you can calculate the velocity, right? You can calculate the velocity. So let me calculate with the calculator. 90 divided by alpha x to the power, to the power 1 divided by 0.45 alpha equals bracket 60 divided by alpha x bracket close to the power 1 divided by 0.3 bracket close, shift solve equals. So you will get the velocity. Let me wait. The velocity will become 26.68 meter per minute, right? Got it? So this will be our answer. I hope the question is pretty clear to you. This type of question was asked, okay, many times this type of question was asked. Now let me proceed further. Now I will discuss the extended or modified Taylor equation, right? Extended or modified Taylor equation. In extended or modified Taylor equation, basically what we do in extended or modified Taylor equation, we not only depend on the cutting velocity. Got it? We not only depend on the cutting velocity, we also consider the feed and depth of cut, right? Basically, in the initial equation, what you have seen? You have seen in the initial equation that V T to the power n equal to C, that the tool life will depend on the cutting condition and cutting velocity along with the tool material. But here in extended modified equation, what is there? That is, there is V velocity into T to the power n, F to the power A and D to the power B equal to C. Dear student, here V as usual is what? Cutting velocity. As usual, here V is what? Cutting velocity. right? As usual, it is what? Cutting velocity. Okay, cutting velocity in meter per minute, right? Here T is what? Tool life. Here T is what? Tool life, and the unit should be in minute, right? Okay, I hope you understand. I hope you understand in this equation that you have to put velocity in meter per minute and T should be in minute. Okay, always from this equation you get the velocity unit. Suppose that if you are calculating the velocity from that equation, then the unit will be sorry, then the unit will be what? Meter per minute. If you calculate the tool life from that equation, then the unit of tool life should be in what? If it is in the time, then the value will be, then the unit will be what? In minute, right? So in extended modified Taylor equation, here T unit should be in minute, velocity unit should be what? Meter per minute. Here what is F? F is what? Feet. Okay, I will tell you the unit also. And D is what? Depth of cut. D is what? Depth of cut, right? Depth of cut. Now, the unit of feet should be in mm per pass, right? Mm per pass, and the unit of depth of cut in this expression should be in mm, where A and B are the constant, where A and B are the constant. Okay, it depends on the condition. So, it is given to us. Now, what the equation says to us? The equation says to us that, again I am writing Vt to the power n, feet to the power A, depth of cut to the power B equal to C, right? Equal to C. Now, what will be the tool life? Tool life you can write, C divide by okay, velocity, okay, C velocity, feet, and here depth of cut, and the power is what? 1 by n. The power is what? 1 by n. The velocity power is what? 1 by n. Feet power is what? A by n. Depth of cut power is what? B by n, right? So you can see that the tool life is not only depend on the velocity and cutting condition, but also it depend on the feed and depth of cut. Am I clear? Okay, nice, very nice. Here, see the power of the velocity, that is what? 1 by n. The power of the velocity is 1 by n. Now, I am converting this power in a same format. In a same format means, you know, here A by n is there. Now, instead of A by n, I can write 1 divided by n by A. Okay. Instead of that, n by A is another constant, let's say n1. Now, B by n, okay, you can write 1 divided by n by B, okay, n by B, you can write what? N2. Now, when we compare this constant, whenever it's your wish, in the process, whenever you want to compare, you can compare. And it was observed many times that the power of the velocity, that is 1 by n, is greater than the power, okay, greater than the power of feet, that is 1 by n1. And the power of feet, that is 1 by n, is greater than the power of depth of cut, that is b by n, you can write 1 by n2, right? It was experimentally observed. It was experimentally observed, right? So, be sorry. Today I will not see your comment because as you know, I have to cover tool life, okay, and today I have to finish the tool life with covering each and every important aspect, okay. But meanwhile, if you have any doubt regarding the tool life, okay, then you can ask on my Telegram group. So don't worry about that. Got it? Now, shall we move? Okay, so shall we move? Now, the velocity power is 1 by n, feet power is 1 by n1, and depth of cut power is 1 by n1. Means, when you change the velocity, right? When you change the velocity, then the change in velocity is what? High, because power is high. If you change the velocity and its power is high, and it is in denominator. It is in denominator, so it will affect the tool life so much. So velocity will affect the tool life so much. Now, if you change the feet, okay, by the same amount, let's say by the same amount, now you are keeping velocity and depth of cut constant. Now you are keeping velocity and depth of cut constant, okay. You are only changing feet by the same amount, which let's say whatever you are changing. Suppose if you change, suppose I will take the first case. Suppose if I am changing V, if I am increasing V, 25% if I am going to increase, and if I am keeping feed and depth of cut constant, then what they observe, that the power of velocity is high. So it will be increases more, and it is in the denominator, so it will affect tool life more. Got it? Now in the second case, now if you change the feed by the same amount, but here you are keeping velocity and depth of cut constant, here I am keeping feed and depth of cut are what? Constant, right? Constant. And here I am keeping velocity and depth of cut what? Constant. Now, if you change the feed by 25%, here the power of feed is less compared to the velocity power. So change in feed is less, so it will affect the tool life less as compared to the cutting velocity. Now the third case, if you only change the depth of cut by, let's say, 25%, and keeping velocity and feed constant, then you know the power of depth of cut is very less. So change in depth of cut is less, so the tool is going to affect from depth of cut is very less. Got it? Very less. So that's why I am writing here note, and this note is very useful and important, that cutting speed, has the greater effect, greater effect followed by feed and depth of cut, okay, followed by feed and depth of cut respectively, right? Respectively. Noted? So it is a very important note. I hope you understand this note. Now there is a question, okay. Now here you can see the tool life. Here you can see the question is based on what? The tool life, and here we are considering all the parameter in the question, right? See what the question is saying. The question is saying that the tool life equation for HSS, is what? That much, and I hope it is visible to you. So please note down Vt to the power 0.14, right, feet to the power 0.7 and depth of cut to the power 0.4. Okay, the tool life is 30 minutes is obtained using the following cutting condition. Okay, basically it is the initial tool life T0 30 minutes, right, where V0 is 45 meter per minute. Here feed, basically this tool life will comes when velocity is 45 meter per minute, feed is 0.3 mm and depth of cut is 2 mm, right. Here V0 is given, F0 is given, that is 0.35 mm, and the depth of cut is 2 mm is given, okay, D0 initially. Now, if the speed, feed, depth of cut are increased individually by 20%, 25%, then the tool life is. Means if we are increasing all of the parameter, then what will be the effect on a tool life? Okay, what will be the effect on a tool life? Okay. So, now first of all I think I need a C also, because in upcoming calculation I need the value of constant. And you know from the equation that V naught T naught to the power 0.14 F naught to the power 0.7 D naught to the power 0.4 equal to C. Now V naught is what? 45 meter, okay, into T naught is what? 30, 0.14, F naught is what? 0.35, 0.35 into to the power 0.7, and D naught is what? 2 mm, 2 mm to the power 0.4 equal to C. Now, calculate the value of C. Okay, calculate the value of C. Let me see whether the value is right or wrong, whether the value is right or wrong. Okay, maybe the data is not perfect. Okay, and no, data is all right, perfectly right. So what will be the C? 45 into 30 to the power 0.14 into 0.35 to the power 0.7 into 2 to the power 0.4. Now, what is C is coming? 45.842, right? C is coming 45.84. So, the value of C is 45.84, okay, 2. This is the value of C. Now, if you are increasing, okay, if you are increasing, let's say if you are increasing velocity by 25%, if we are increasing, let's say velocity, feed and depth of cut increases, okay, upward arrow means increases, okay, by 25%, then the new velocity will be what? V equal to 45 into 1 plus 0.25, right? So 45 into 1.25, it will become 56 point, okay, it will become 56, okay, it will become 56.25 meter per minute. Remember the unit, okay, remember the unit. Your feed is what? Feed is, okay, feed is, initial feed is what? If you increase the feed by 25%, then feed is what? 0.351 plus 0.25, right? So 0.35 into 1.25, it comes 0.43, it comes 0.4375 mm, okay. Now, what will be the depth of cut? If you increase the depth of cut by 25%, then it will be what? 2 into 1 plus 0.25. I hope we are increasing by 25%. No? That's why 1 plus 0.25. This is a basic mathematics, you can understand. I hope that. So, 2 into 1.25, it is coming 2.5. Okay, depth of cut is coming 2.5. Right. Now, you have to calculate what? Tool life. So, I am calculating the tool life. T equal to what? 2 equal to C. Okay, C is what? C is 45.842, 45.842 to the power is what? 1 divided by 0.14, right? 1 divided by 0.14, 1 divided by 0.14, divided by, you can write, what you can write? Yes, velocity. What is the velocity? Velocity is 56.25, right? 56.25 to the power 1 divided by 0.14, right? You just have to put the value in this equation, that's it. Okay. Now feet 0.7 na, so feet, the value of feet is what? The value of feet is 0.4375. Okay, 0.4375 to the power 0.7 divided by 0.14. Now the depth of cut is what? 2.5, and the power of depth of cut is what? 0.4. So you can write 0.4 divided by 0.14. Right. Now you can calculate the tool life. What it will be? Let me calculate. 45.842 to the power 1 divided by 0.14, 0.25, 1 divided by 0.14, okay, into 0.4375, okay, to the power 0.7 divided by 0.14, right, into 2.5 to the power 0.4 divided by 0.14. Now it is coming 1.055 minute, right, 1.005 minute. This is my answer. I hope you understand the logic. Okay. Now the next part is economics of metal cutting, right. Here let us see, this graph is a very important, okay. Generally here the cutting cost will depend on, you can say, a cutting velocity, and the cutting cost has a two parameter. Cutting cost will depend on two parameter. One parameter is the cutting cost and the other parameter is tool cost, right. I will explain. Here you can see there is a graph, okay, there is a graph, and this is the graph, okay, this is what? This is the graph. Now here the here on y axis is cost per unit volume, okay, or I will simply write cost, or on x axis I simply write velocity, right, velocity. Now look here, cutting cost means you are paying someone to machine the workpiece, okay, to machine the workpiece, then that cutting cost will decreases, okay, will decreases when you increase the cutting velocity, and after some time it behaves like this. So this is what my dear student, this is what? This is cutting cost. This is cutting cost. This is cutting cost. Right. Now the tool cost is what? The tool cost is when you increase the cutting velocity, then the tool wear will be what? High. Okay. Then the tool cost is also increases. Okay. It will increases like this. It will increases like this. So this is what? This is tool cost. Okay. This is tool cost. So basically the total cost is what? The total cost is the sum of your cutting cost plus tool cost. So this is a total cost. This is a total cost. So you can write the total cost is, you can write that the total cost is what? Cutting cost, okay, cutting cost plus what? Tool cost, plus what? Plus tool cost, plus tool cost, right. This is a total cost. Now you can see that the total cost is varying, and the total cost, okay, the total cost will be varied. Suppose that if you cut the workpiece at that velocity, let's say the velocity is V1, that the total cost is this. If you, and this velocity is low, see, if you cut a workpiece with a very high cutting velocity, let's say V2, again the total cost is what? Almost high. And what you want as a manufacturer? As a manufacturer, you want that your cutting cost should be what? Your cutting cost should be minimum. Am I right? As a manufacturer, you want that your cutting cost, total cutting cost, not a cutting cost, total cost should be minimum. So I want that my total cost should be minimum. So you can see this is the point where the total cost is what? Minimum. Okay. So that velocity, my dear student, that velocity is known as a V optimum. That velocity is known as V optimum, where the total cost of the machining is what? Minimum. So that velocity we want, right? That velocity we want. And it is obvious that if you are using that velocity, okay, for a cutting, for a machining the operation, okay, then there will be a relevant what? Tool life. Then there will be a relevant what? Tool life. And we are studying the chapter of tool life. So we want to know that what will be the tool life which is corresponding to V optimum, at which the total cost is what? Minimum. For that you have to learn this formula. Okay. For that you have to learn for this formula. The formula number 1. Okay. Formula number 1. What is the formula number 1? Formula number 1 is optimum tool life for minimum cost. Means it is that tool life, basically it is that tool life, okay, it is that tool life which is depend on that velocity on which the total cost is what? Minimum. Okay, where this is V optimum, basically where the total cost is minimum, where the total cost is minimum, and at which we want to know the tool life. And what is that? I will write again because it is not clearly visible to you people, that T naught equal to Tc plus Ct by Cm into 1 minus n divided by n, right? Now what is Tc? I will explain each and everything, don't worry. Tc will be a tool changing time. Suppose that if you are doing a machining operation, right, and if the tool is what? Wear out, then what you do? You repair the tool. For that you want to unmount the tool, and after repairing you are going to mount the tool. So that is a tool changing time, na? That is a tool changing time. Okay, Tc is a tool changing time. So it is written that Tc is what? Tc is tool changing time in minute. Now again Ct. Ct is what? The tooling cost. Okay, Ct is what? The tooling cost. The unit is rupees per service. Means suppose you are servicing a tool. Okay, so you will charge a person. Okay, you will charge a person. Okay, after the service is completed. So that is a cost, that is rupees per service. Once the service will be completed, then the charge will be paid to that person. Once the repairing will be done, then I will give you the amount. Okay, so always remember the unit of the tool cost should be rupees per service, or whatever cost. Suppose that in a question there are lot of cost will be given. Suppose that in a question, if there are lot of costs are given, then student sometime confused. That sir, which is that cost? Very easy. The cost which has a unit rupees per service is always your tooling cost. Simple, rupees per service. Got it? The next cost is your machining cost, and its units it's rupees per minute. Whatever cost you find in a question, and if the unit is what? Let's say rupees per minute, then the cost will be what? Then the cost will be machining cost. Got it? Machining cost. Now there are some hidden costs also, okay, which maybe you are not able to understand, but during question you will understand that concept. For that I'm going to solve a ESC conventional question, which will give you a better scenario. Now tooling cost, sometime tooling cost, there are a lot of hidden costs. Okay, and those costs, if those costs has a unit of rupees per servicing, then you just add those costs. Suppose in a question, if two costs are given and whose unit is rupees per service, so simply add these two costs. Got it? Simply add these two costs. So tooling cost is what? Tooling cost is tool regrinding cost plus tool depreciation per service. Hope you understand. I hope you understand. Okay, I will explain through the numerical. I am going to solve a question. In that you will understand this expression. Tooling cost is tool regrind cost plus tool depreciation per service. What happened now? When you servicing the tool, then every time the tool become older, okay, and every time there will be some cost remaining. That cost we consider also as a tooling cost. Now, the next cost is machining cost. So, whatever the cost you are going to see whose unit is rupees per unit, rupees per minute, just add those costs. Labor cost if the unit is rupees per minute, and overhead cost whose unit is rupees per minute, then add those costs. Okay, clear? Now, let us try to understand this concept by a numerical. In this question, I have to determine the optimum cutting speed for an operation on a lathe machine using following information. And what are the information? Tool changing time is given, that is TC is given, tool regrinding time, okay, that is TR is given, okay, TR is given, machine running cost means you are doing a machining operation, so CM is given, okay, depreciation of tool regrind, okay, that is given. The constant in the tool life equation are, here the constant is given to us, here the constant is given to us, that is 60 and 0.2, that is C and the index value, that is the C and the index value. Now, you have to calculate optimum cutting speed. Optimum cutting speed what? On that velocity where the total cost is what? Minimum. Now, what you do? You just find out tool life which is related to what? V optimum. Okay, which is related to V optimum. Then we can find that velocity on which the total cost is what? Minimum. Right? So, how can we find? We know a relation, and the relation is pretty simple. Relation is what? Relation is the tool life T naught, okay, that T naught which is related to V optimum, it is equal to TC plus CT by CM into 1 minus N divided by N. Now, N is given. Now, dear student, here CT is not given, and you know the unit of CT, is what? Rupees per service, okay. Maybe some students are going to make it 0, okay. Here CT unit is rupees per service, means I am providing a service to the tool, okay, for repairing, for repairment I am providing a service to the tool, and service means I am regrinding the tool, okay, regrinding the tool. So, this is my service time, this is what? My service time, okay. Tool was failed, so I am doing service on a tool, so that tool become perfect, so that I can use again. So, this is my service time, got it? And during service, basically when the tool is wear out, when the flank become wear out, when the little bit cutting edge is wear out, so we do grinding operation to make the flank perfect, to make the cutting edge perfect, right, to make the cutting edge and flank perfect. So, it is basically a machining operation. So, CT, basically CT is what? And this is the basically up to that minute you are providing the service na, up to that minute you are providing the service na, this is a service time na. After that the tool is perfect, After that tool is ready to use. So you basically here tooling cost is was CM into TR. I am doing regrinding operation, that is machining operation, up to that much time. Okay, up to that much time. Here CM unit is what? Rupees per minute, and TR is what? Minute per service. Minute per service, right? I am writing again. Here. Just cancel it. Look here, tooling cost is what? CM. That is rupees per minute into your regrinding time, that is minute per service, right? So rupees per service. Now after every service, what is the depreciation cost? Sometimes student was confused, sir, what is depreciation cost in tooling cost? Basically student, the depreciation cost at that cost which was reduces with the time. Actually what time? Which was reduces after every service. So this is a cost per service which was remain, and that cost we have to add in the expression, and it is the derived thing, and that cost we have to add in the expression. Just remember that thing only. Are you getting my point? Depreciation is a cost, is that cost which will remain after service, and that cost we have to add. And what I say, which remain after service, so it is rupees per service. And what is the depreciation cost is rupees 0.5 per service, right? 0.5 per service. So add rupees 5. So you will get overall unit is what? Rupees per service, and CM is what? 0.5 into TR is what? 3 plus 5, that is 6.5 rupees per service, right? And CM is what? 0.5. Now find out the T naught. T naught is what? TC, tool changing time is 3 minutes. 3 plus CT. CT is what? 6.5 divided by 0.5 into 1 minus 0.2. 1 minus 0.2 divided by 0.2 equal to. Now you will get the value of T naught, and it will become out 64 minutes. Now what you need? You need a cutting velocity. So what you write? You will write Taylor equation, that V naught T naught to the power n equal to C. Now you know the tool life, and you know the C. C is 60, T naught is 64 to the power what is n? 0.2, and when you calculate this value, it will become out, V naught will become out 26.11 meter, okay, 26.11 meter per minute, right? This is the answer. Now the next thing is that the other formula is formula number 2. I want to know that velocity where the production rate is maximum. Okay, or I want to know that tool life, okay, that tool life where I am getting the maximum production rate. Dear student, there is a graph, okay, there is basically a graph. This is my graph. It is a production rate means manufacturing rate, and cutting velocity, right? Cutting velocity. Now the graph is like this. You can see when you increase the cutting velocity, manufacturing rate increases. When you increase the cutting velocity, manufacturing rate is increases. And at a certain velocity, the production rate is maximum. After that, if you increase the velocity, production rate is what? Decreases. Alright. So I want to know that velocity. Where the production rate. Is what? Maximum. So V production max, where the at the velocity at which the production rate is maximum. So it is obvious that corresponding to that velocity, there will be a tool life, okay, corresponding to that velocity there will be a tool life. So that tool life is Tc into 1 minus n by n, okay, corresponding to that velocity there will be a tool life, that is Tc into 1 minus n by n, right. Tc again tool changing time, and n is what? The exponent, right, n is what? The exponent. Now, to understand these concepts, let us try to solve one question so that you can understand this concept in a very well manner, okay, in very well manner. Let us try to understand in a certain machining operation with a cutting speed of 50 meter per minute, tool life of 45 minutes was observed when the cutting speed was increased from 50 meter per minute to 100 meter per minute, the tool life decreases to 10 minutes. Okay, estimate the cutting speed for a maximum productivity. You want to know the cutting speed where the productivity is maximum if the tool changing time is 2 minutes, right, Tc is 2 minutes. Now, for that you need I think n, okay, because we know the velocity where the production rate is maximum, and whose tool life is will be what? T naught equal to Tc into 1 minus n by n, and we don't know the value of what? N. So we have to calculate the value of n also. So, dear student, I will write again that T naught equal to, okay, T naught is what basically? I will write, don't worry, I will write again. Basically, I want to know that velocity where the production rate is maximum, whose corresponding tool life is Tc into 1 minus n by n, and we want to know the value of what? N. And we know that here two velocities are given, that is what? V1, okay, and that is what? V2. V1 T1 to the power n, V2 T2 to the power n. Here V1 is given that 50 into T1, that is 45 minutes to the power n, into your velocity V2, that is 100, into T2, that is 10, okay, T2 that is 10, that is 10 to the power n. Now, you can solve, you will get the value of n. You can solve, you can get the value of n. And what will be the value of n here? Okay, the value of n comes 0.46, right, 0.46. Now, find that tool life, okay, find that tool life where the cutting velocity is maximum, find that tool life. So, T naught is what? Tc into 1 minus n by n. Tc is what? Tool changing time, that is 2 minutes, into 1 minus 0.46 divided by 0.46, T naught equal to, so T naught will becomes out 2.34 minute, right, 2.34 minute, is it clear? It is a 2.34 minute. Now, you know the T naught, so what you do? You now, I think you know the, we need a value of C also, okay, because when we use the Taylor equation V naught T naught to the power n equal to C, and we want to know that velocity where the production rate is maximum, because we know that tool life, okay, because we know that tool life which is corresponding to V naught. So, we need a value of C also, okay, we can find out, okay. Now, V naught equal to C, and C is what? Let us say V1 T1 to the power n divided by your T naught to the power n, right. So, just write V1 is what? 50 T1 is what? 45, 0.46 divide by T0 is what? 2.34 to the power 0.46, right? To the power 0.46. I hope 2.34 to the power, okay. So your V0 will be what? 195 meter per minute, right? So this will be the cutting velocity, where the production rate is what? Where the production rate is, where the production rate is what? Is maximum, is maximum, right? Is maximum. I hope you understand. I hope you understand, right? Now, the surface roughness concept. Surface roughness concept. Here the surface roughness, basically suppose that we are doing a cutting operation by a single point turning tool. Okay, then in an ideal case, formula number 1, in an ideal case, when the nose radius is what? 0. Nose radius is 0, what does it mean? That the tool remain, okay, very sharp. There is no curvature on the tool tip, tool is very sharp. So what will be the roughness? What will be the roughness? It is feed divided by 10 of side cutting edge angle plus cot of end cutting edge angle. Okay, cot of end cutting edge angle, cot of end cutting edge angle. Okay, this is what? This is, you know, side cutting edge angle, and this is what? This is what? End cutting edge angle. This is a feed. And if you take a average roughness, average RA represent average roughness, just divide the above expression by 4. Suppose that in a practical case, if you consider, okay, generally in practical case, there is a curvature, there always be a curvature on the tip of the tool, there always be a curvature. Why? Because due to wear, the tip become rounded. Okay, maybe initially you will take a sharp tip tool whose radius of curvature is 0, but during machining the tool will be wear out, and due to wear, what happened? Due to wear, the tip become what? The tip become rounded and nose radius will be appear. In that case, the roughness is what? F square by 8R. And if you want to know the average surface roughness, that is F square by 18 root 3 R. So please remember this formula, it will be a very useful, okay, it will be a very useful. Now there is a question in a GATE 2005, and what was the question? There are two tools, one tool is P and other tool is Q, whose signature is given according to ASA, tool P signature and tool Q signature according to ASA, whose tool radius is 0. Look, whose tool radius is 0, whose tool radius is 0. They are used to turn a component under the same machining condition, means machining condition is same but tool is different. Okay, if HP and HQ, if HP and HQ, right, denotes the peak to valley height, that is the roughness of a surface produced by tool P and Q, the ratio of HP by HQ. Dear student, you know, roughness is what? In ideal case, when nose radius is 0, F divided by 10 of side cutting edge angle plus cot of end cutting edge angle. Here tool signatures are changes, so angle will be changes, but other cutting conditions are same, like feed is what? Same. So I can write, basically it is directly proportional to what? 10 of side cutting edge angle plus cot of end cutting edge angle. So how can I write HP by HQ? HP by HQ, basically it comes out 10 of CS plus cot of CE of Q, right, of Q, divide by 10 of CS plus cot of CE, okay, of what? Of P, right, simple. So what can you write? 10 of side cutting edge angle of Q, What is Q? Q. Side cutting edge angle. What is 50? It is 50 plus cot of end cutting edge angle, that is 8 of Q, divide by 10 of side cutting edge angle of P. P, side cutting edge angle of P is what? 30 plus cot of end cutting edge angle of P, that is 8. So this is HP by HQ. So the answer will be your B. Okay. Now at the end of the session, if you have any doubt, you can first of all revise the thing. Still, if you have any doubt, your doubts are openly welcome on my Telegram group. Okay. And at the end of lecture, you will receive all the notes on your Telegram group. Thank you.